Chapter 7, Section 6, this is Part 1 of Function Operations. So here we're going to see some combined functions and some composite functions. All right, old school functions. Well, we look at the picture of the first graph. It's linear. All linear functions should have arrows. So should the quadratics, the parabolas. So I'm going to draw arrows on those. I could figure out the equation of this line. The y-intercept is -1. Slope to get from this point to this point, I'm going to rise 1 and run 2, so slope is 1/2. This equation is y equals 1/2 x subtract 1. Function notation. If we know it's a function because it passes the vertical line test, we can use function notation and replace the y with f of x. The equation is the same, nothing changes there. It's just the y turns into f of x to indicate its function notation. The domain, well, that's all my x values. All the x values found on the graph of this function would be all of them because of these arrows, yes? So farthest left and farthest right on the x-axis, the domain is negative to positive infinity. So we're revisiting the domain and range. The range, same thing, because of the arrows, eventually all of the y's, both positive and negative, will be encompassed on the graph of this function. So negative to positive infinity again. To find something like f of 7, we want to evaluate the function when the x value is 7, right? This is f of x. The x value is 7, so you go back up into the original function and you substitute a 7 in for the x. 1/2 times 7 is 7/2. Subtract 1, well 1 is really 2/2. 7/2 subtract 2/2 is 5/2. So f of 7 equals 5/2. The second equation is not linear, it's quadratic. It's a parabola. This we could check to see if this is the parent function. Well, 0, 0. 1 squared is 1. Now notice here, this is going by halves, really, right? This is 1/2, this is 1. That's 1 1/2, that's 2. So here's where my 1. 1 squared is 1. 2 squared is 2, 4. This is the parent function. Okay, right there are the ordered pairs for the basic quadratic. Y equals x squared. Function notation. Well, we called this one f of x, so we're going to call this one g of x. Still function notation. Equals x squared. The domain. Any x value will be found on the graph of this function, so the domain is negative to positive infinity. The range. There is a lowest point on the graph of this function. Remember, the range are your y values. This thing starts at and includes the 0 and goes to positive infinity. So I need a bracket on the 0, goes to positive infinity. Oops, sorry. Again, bracket on the 0 goes to positive infinity. G of -3. Remember, this is an x value. So my function is x squared. Put the -3 in there. Square the -3, you get 9. So on this function, g of -3 equals 9. Okay, this is somewhat of a review. We've done stuff like this way back in the beginning of the year. Now let's look in putting these two functions, which is this one and this one. And we want to add add the two functions. So if you look down here, f of x plus g of x. Well, f of x is 1/2 x minus 1. Add to it g of x, x squared. Now we're going to clean it up. F of x plus g of x is equal to, I'm going to put the quadratic because the highest power should be first in order of descending powers, x squared plus 1/2 x minus 1. The domain of a combined function is elements that both f and g have in common. They have to be in both f and g at the same time. Now notice the domain. We already figured out the domain for both functions up here. The domain of the f function goes from negative to positive infinity. The domain of the g function goes from negative to positive infinity. So guess what? The domain of the combined function is also negative to positive infinity because they will have all elements in common. So again, the domain of a combined function, elements that f and g both have in common. All right, they both have negative to positive infinity in common. So, for example, if they did not both go from negative to positive infinity, like this example right here, and I'll highlight it so we can see it better. The domain of f of x is negative infinity to 6, and the domain of g of x is 2 to infinity. Find the domain of f plus g of x. I'm going to draw a number line. And I'm going to put a 6 on the number line and a 2 on the number line. So I'm going to put my 0 here, put my 2 here. I'm going to say 6 is about there. I'm going to use different colors to model this. Negative infinity up to and including 6. Well, that's a bracket on 6. And that's a shade to the left in the direction of negative infinity. The domain of the g function is positive 2 to infinity, including the positive 2. And now I'm looking here to see where the two colors overlap. You see, this part here is just green. And this part here is just red. This part here is both green and red in between the 2 and the 6. So the domain here is 2 to 6. Okay, so sometimes it helps if you draw a little number line and put the domain of both functions on the same number line and look for where they overlap. Function operations. When you operate on two functions, you get a combined function. Addition. We're going to add two functions. So when you see the notation f plus g of x, or for subtraction, f minus g of x, or when you see multiplication, f times g of x, or division, f divided by g of x. These really mean, well, f plus g of x really means f of x plus g of x. And f minus g of x is f of x minus g of x. And f times g of x means f of x times g of x. And of course, f divided by g of x means f of x divided by g of x. Now what you need to keep in mind is g of x is in the denominator. So this would be true provided g of x is not equal to 0. Right? Division by 0 is undefined. You can't have a 0 in the denominator. All right, a couple examples on page 2 of the notes. If you have any questions on the function operations, please let me know. If you have any questions on the domain or the range, please let me know. All right, this says if f of x equals 3x squared plus 5x minus 2, I think I'm going to highlight that. And g of x equals x plus 2. Perform each function operation. And then find the domain. Don't forget about finding the domain. F times g of x. Well, that really means f of x times g of x. You must use parentheses. F of x is 3x squared plus 5x minus 2. G of x is x plus 2. Now we need to multiply. You could write the binomial in the front. I like to do that. Or you could FOIL it out. Well, it's not really FOIL, but you could distribute. It's double distributive property is really what it is. You know, it's going to be x times this one, and this one. And then it's going to be 2 times this one, and this one. So if you want to set it up like that, x times this one and this one, that one. Always put plus in between. 2 times this one, and this one, and this one. Sometimes students like a better visual. You don't have to do it this way. 3x squared times x is 3x cubed. Here I've got a 5x squared minus a 2x plus 6x squared plus 10x minus 4. Combine like terms. Cube first. 3x cubed. Quadratic plus 6x squared. Linear. I've got 3 linear terms. 5 minus 2 is 3 plus 10 is 13. And of course, don't I see a mistake? This should be 5x squared. So 6 and 5 is 11x squared. Sorry about that. I was wondering, why did I have 3 linear terms? And I shouldn't have. Okay, so back to linear terms. I've got 2 of them, so plus 8x. And it appears as though I have only one constant. All right, so my final answer here, f times g of x is this 3x cubed. I'm just writing it again because of the goof. Now, the domain. There are no restrictions here. The denominator is never going to equal 0. Never, never, never. So, there are no restrictions. And because there are no restrictions, the domain is negative to positive infinity. Okay, so if you have any questions, please let me know. G minus f of x. G minus f of x. Well, That's going to expand as g of x minus f of x. And I think you could pause the video here and just substitute the g in for g, the f in for f. Remember, you need to use grouping symbols, especially with subtraction, and see what you come up with. Okay, hopefully you pause the video and substitute it in. What I did in the next step after I substituted the g function in for g, the f in for f, was to distribute the negative. And then I combine like terms. Notice again here, the denominator is 1, right? This is over 1, so there are no restrictions. You know, the restrictions are, what can't x be? And so again, because there are no restrictions, the domain is going to be negative to positive infinity. I had to pause the video for the announcements. So again, what I was saying is, you know, the restrictions are what x can't be. So if you have a variable of x in the denominator, you have to look for what x can't be. And x can't be a value that will cause me division by 0. All right, so restrictions and domain, they're related because you need the restrictions to get the domain, but the restrictions itself is not the domain. Okay, if you have any questions, please let me know. All right, last problem to do. F divided by g of x is really f of x divided by g of x. And f of x is 3x squared plus 5x minus 2 over the g function x plus 2. Now notice here, x cannot equal negative 2. This is a restriction on the variable. Because if x is negative 2, I get a 0 in the denominator. You have to take these a step further and try to factor this if you can. Right? This one does factor. Okay, 3 and 1, 3x, 1x. That's the only way I could do it. And 2 is only 2 times 1. Those are both prime numbers. I'm looking to get a 5 in the middle. If I put a 2 here, that's 6 minus 1 is 5. The signs are not the same. The larger product is positive. And so that does factor. Now notice what's going to happen here is these two common factors are going to divide out. And so my final answer here, f divided by g of x, is equal to 3x subtract 1. Provided x is not negative 2. You must include the restriction as part of the answer. It's part of the answer. Okay, this whole thing goes together. Now, because negative 2 is a restriction, my domain is going to change from negative to positive infinity. Of course, x can be anything except this. So I am starting at negative infinity, and I am ending at positive infinity. But I have to restrict the negative 2. Okay, and it's got to be parentheses because it's not included, and you put your little u in there for in union with. Please use the u. It's just a thing that you must do. Put the u in between. Okay, so one more time. X can be anything except negative 2. So we go from negative to positive infinity, but we have to skip over that restriction. Okay, and this is the only way we can show that we're skipping over that one restriction. So if you have any questions on these combined functions, please let me know. Ask in class. And give it your best effort. Have a great day.